Hi, in this video we're going to use a quadratic graph to work out its equation in expanded form. Now we're given the x-intercepts, which are here, also known as roots, and we're given this y-intercept, and that's the only information we're given about this quadratic graph. Now let's suppose we were doing the opposite. We were given the equation of the graph, so like let's say y is equal to x plus 1 times x minus 2. Now remember that to find the x-intercepts, so the points where the graph cuts the x-axis, we made y 0. So if we made y 0, so I'll shoot y for 0, you get this. And then remember, if you have a product of two things is 0, either the x plus 1 is 0, in which case x is minus 1, or the x minus 2 is 0, so x would be equal to 2. And remember, the quick way of doing it is just to sort of negate this number. So this plus 1 in the bracket becomes minus 1, and the minus 2 becomes plus 2. And that gives you these two x-intercepts, which we're going to put on the x-axis. And then the quadratic graph is going to look like something like that, right? So we can do the same here, but in reverse to say, well, if we negate these two values, those are going to be the numbers in the two brackets of our quadratic equation. So let's do that. We've got y equals, and then two brackets, and then this minus 5 here, we're going to negate to become plus 5, so x plus 5, and then this 8 here, we're going to make minus 8, so it's going to be x minus 8. Now, if you had these brackets here, it gives you the correct x-intercept, but it might not give you the right y-intercept. And the way we fix that is we just put some constant on the front, let's call it k, some unknown constant, because what the k does is it scales the graph vertically to make the y-intercept correct, right? Now, we know that it goes through this point here, the y-intercept of minus 120. Now, this is a coordinate, is just 0 minus 120, isn't it? So we're going to use that to substitute into our equation to find the value of k. So if 0 minus 120 lies on this graph, we can sub this as the x and the y. So we're going to get y is minus 120 is equal to the k here, k multiplied by x plus 5, which is 0 plus 5, because we're substituting in x is 0, which is 5, multiplied by x minus 8, so it's 0 minus 8, which is minus 8. So we substituted the x and the y in. Now, if we just simplify this, we get minus 120 is equal to, that's going to be minus 40k. So that gives you k is equal to positive 3, right? So now we know that the equation of our quadratic curve that goes through all those intercepts is going to be y is equal to 3 brackets x plus 5 x minus 8. We've just substituted the k for 3 that we've worked out. Now it wants it in expanded form here, so we just need to expand out our brackets. So I'm going to just expand out, well, I'm going to do the 3 times the x plus 5 first. So the 3 times the x is 3x, and the 3 times the 5 is plus 15. And then we can just times it by this x minus 8 here. So we need to expand out the two brackets. So each thing in the first bracket times each in the second. We do the 3x times the x, which is 3x squared. We've got the 3x times the negative 8, which is negative 24x. We've got the 15 times the x, which is 15x. And we've got 15 times negative 8, which is minus 120, I believe, I hope. And then we just collect like terms. So we've got 3x squared. The minus 24x plus 15x is equal to minus 9x. And we've got that minus 120 like that. And there we go. That is our final equation of this quadratic curve.